Hello everyone. I'd like to make a small video, I'll keep it small, on significant figures and accuracy and precision. I'm getting some tests back and there's confusion. And I know because when I taught face-to-face, it was hard enough to teach face-to-face accuracy and precision and significant figures. So I can imagine trying to learn online is difficult. So hopefully this helps. Let's start out with significant figures. There's 3 rules, but if I explain this to you this way, maybe you don't have to memorize any rules at all. I like to start out by looking at this number, 0.075, and I put units after it because when we're talking about, in this section, we're doing measurement. So precision and accuracy only comes into play when we're measuring, when we're putting something on a scale or we're measuring something with a ruler. And that's when we start talking about significant figures and accuracy and precision. So I put kilograms after it. Now, this number, 0.075, I'd like to say first, that 0 does not have to be written. It's written there just like in the English language where you might put a comma somewhere, just so the reader of the number will recognize that decimal point. But I had to look that up because that 0 really doesn't need to be written. I never write it, but your calculator displays it. Anyway, I'm getting off the point. Okay, so 0.05 kilograms. If I can rewrite that, because this is the metric system, as 75 grams. Because when you multiply this by 1,000 or you move the decimal point to the right 3 hops or you use your King Henry rule, you get 75 grams. So if we all agree with this, then there's only 2 significant figures here. These leading zeros are just placeholders, and you might have heard it that way before. Placeholders are not significant. So leading zeros are never significant. And I like to go like this with my pencil. Go along with your pencil, and all zeros are not significant till you hit the first number. All right. So that takes care of this first rule, leading zeros are never significant. Darn, I keep hitting that tonight. Okay, now in between zeros are significant. And with this explanation, had there been a 0.705 in there, I think that's clear. So you don't have to memorize that. In between zeros are going to be significant. Even if you use your pencil and there was a 0 stuck in there, you'd count it. Trailing zeros is all you have to think about. So when you're going along a number with your pencil and you're hitting zeros, they're not significant. When you hit the first number, you start counting. And then the zeros at the end are what you don't know whether to count as significant or not significant. Okay, let's look at these 2 measurements. And this may help you never to forget. As we go along here, there's no initial zeros. So we have 7,03906. There's 6, all right, I'm gonna say it, sig figs in that number. Okay, this number, 7, there's no initial zeros, 1, 2, 3, 4, 5, 6. All right, what about this? Here's the explanation for trailing zeros. The person that made this measurement would not have bothered to write a decimal point and a 0 had that person not measured that far and rounded. So the rule becomes, if there's a decimal point in the number, a trailing 0 is significant. If there is no if there is no decimal point in the number, the trailing 0 is not significant. So let's say we have 7060. How many significant figures? 1, 2, 3, trailing 0. Are we going to count it or we're not going to count it? There's no decimal point here. That means that the person that was doing the measuring didn't measure out farther than that. Okay, these are the rules that scientists have to make up so that they can follow and understand each other, just like when you're writing an English sentence, you have to have rules. So I hope that clears up the significant figure stuff. Leading zeros never count, in between zeros always do. Don't have to think about that one. It's the trailing 0 ones. If there's a decimal point in the number, count the trailing 0. If there is not, do not count the trailing 0. So this has only 3. And what do we say? This one's going to have 1, 2, 3, 4, 5, 6. We're going to count this. So this one has 7. Okay. What did I write here? Trailing 0 is only significant if the number contains a decimal point. Okay, hopefully that clears up this trailing 0 stuff. All right, I'm going to flip over here and talk about accuracy and precision. Okay, accuracy versus precision in measuring. We only talk about this when measuring and we're using scales or slide rules or whatever you're using to measure. And I like to explain it this way. Let's say you're at a grocery store and you're buying a 1 pound bag of potatoes. And it's a 1 pound bag. It's marked 1 pound on it. And let's say you put it on the scale and you come up with these numbers. Okay, I didn't look through the Newton. I'm sorry, I didn't look through all of that Newton homework because I have to get them wrong to get them right. But if you ever see the bullseye explanation, I like that because 1 pound is here, and these measurements are all pretty close there to that. So they are accurate and precise. Accurate means the numbers are close to home, and precision means the numbers are similar. So this happens to be accurate and precise. Okay, let's say we had 3 numbers that were really, really close together. 2.5, 2.51, 2.19. They were nowhere near the value of the bag of potatoes, but they were close together. They're still precise. They're close together, but they don't have to be on target. Accuracy, you need to be on target. Let's say you take that bag of potatoes home, put it on another scale, your bathroom scale. So 1 pound's here, so you got a 3 and a 4 and a 2. I mean, these dots are nowhere close to home. I mean, close to what I meant by that was close to the real value. So they're not accurate. Okay, so precision, here's your rules. Precision, if the numbers are similar to each other, then we can say they're precise. We don't know if they're close to the true value, but we know at least that the device is measuring precisely. Might not be accurate, but it's precisely or precise. Okay, say you're measuring something and the numbers are really close to the true value of what you're measuring, then they're accurate. So if somebody went and got on a scale and you weighed 100 pounds and the scale told you that you weighed 200 pounds, that's not very accurate. But if you got on it 3 times and it said 200 pounds, 201 pounds, 199 pounds, they're precise. I mean, the bathroom scale is measuring precisely, but it's not accurate to your true weight. All right, now let's get to the multiplying and dividing part. The rules are, and I'm going to get into why, that's not what we're going to do here today. We're going to talk about your rules. You just need to remember when you add numbers, you use the rules of precision. So when you add, you use the rules of precision, and when you multiply, you use the rules of accuracy. Okay, and this is what this means. I wish I would have put addition first, but anyway, the rule, when multiplying, use accuracy. And what that means is how many significant figures are in the number. So if you have two numbers, you're multiplying together, and these are measurements, by the way. The result can only be accurate as the least accurate in the equation. Your key word here is right here, the least significant, the least accurate. Okay, so how many significant figures is how you determine accuracy. This has 1, 2, 3 significant figures. This has, don't count the 0 because it's a leading 0, 2 significant figures. So your answer can only have the same number of significant figures as the least accurate in the equation. That's all you can really depend upon when you're measuring. So 2 significant figures your answer needs to have. When you do the punch this in the calculator, you get 0.3096. How many significant figures does it have? Well, you don't count this one, so 1, 2, 3, 4. 4. Your answer, you can only have 2 if you're using the rules of accuracy. So let's round to 2 significant figures. That would be rounding to the 100ths place. So you check out the number beside it. It's bigger than 5, so your answer is equal to, I'm going to recopy that, 0.31. This is a test question for a student that I'm grading a paper for right now, so that student will know who they are. And I don't mind doing this because anyone that hasn't taken the test yet, your numbers will change. So multiplying, use accuracy. Accuracy means how many significant figures. Precision, when you're adding and subtracting, you use precision, and that means the place of the last significant figure to the left. That means how many decimal points out you go to the left. Sorry, to the right. It's a little dyslexic here tonight. Okay, so rule, when adding, use precision. So that means you check out the decimal place. Answer can only be as precise as the least precise in the calculation. I thought that's an equation. In the calculation. So when you're adding and subtracting, use precision. And precision refers to the place of the last significant digit to the right. So both of them are P. Precision, the place, the decimal place. This is an example of somebody's test. They got this one right. 9.99 plus 1.001. On the calculator, you end up with 10.991. By the way, I put a little squiggly there because that means approximately. You don't change it to equal until after you round using your rules of accuracy or precision, depending on if you're doing multiplying or adding. We're adding here, so we're going to use precision. Okay, that means that this number here is precise to the last decimal place of the significant figure to the right. So this is precise to the 100ths place. Where'd my fingers go? There we go, to 100ths place. This one has how many, well, first of all, it has 1, 2, 3, 4 significant figures. We'll just do that for practice. But it is precise. When you're talking about precision, you look at the decimal place of the last significant figure to the right. So this is precise out 3 decimal places. Some people like to write it precise to 3 decimal places. Or you could write precise to the 1,000th place. Okay, this is a test question. The answer asks you to use precision. Actually, it doesn't tell you which one to use, precision or accuracy, but since we're doing addition, we use precision. Precision means the placeholder of the least significant. Your answer you can only depend on when you're measuring the number that has the least significant figures in it. So this is precise to 2 decimal places. This is precise to 3 decimal places. Your answer has to be precise to the least one, this one, 2 decimal places. So 10.99, the ones, you're gonna round it here, the one's gonna make it stay the same. So down here is your answer, 10.99. So you rounded it to the 100th place, which is the least precise. So multiplying, use accuracy. That means how many significant figures. And your answer can be only as accurate as the least accurate in the equation. When adding, use precision. Your answer can only be as precise as the least precise in the addition, in the equation. And precision refers to the place of the significant figure furthest to the right. I'm gonna stop here because it's gonna take too long to upload, and then I'm going to make another video for a couple students and send them directly to them with their missed questions. Okay, keep your questions coming.